Hello everyone, welcome back to my channel. Please like and subscribe to support the channel. On this video, we will be continuing from the previous video that we did on practical number 2. I'm going to be explaining how a thermal overload relay works and how to test it and how to read the nameplate in the manual. On the previous video, I was explaining how the contactor works and how to test it. Going into this video, we also have two types of thermal overload relays or thermal relays or overload relays. We have a ABB and we also have a Schneider. We're going to start with the ABB testing. At the top of our overload relays, we have L1, L2 and L3 contacts, which is for our incoming voltage. At the bottom, we have T1, T2 and T3, which is for the load contacts. An overload relay is a safety component that protects an electrical motor from a continuous high current wall, preventing it from overheating. On an overload relay, we have a trip indicator, a manual and a auto reset, and we have a adjustable current setting or trip class selector, depending on how you want to name it. You can adjust it with your screwdriver to your desirable current. A trip test is used to simulate the overload circuits. On the overload, we've got different type of trip classes. You can check on the side of your overload on your nameplate or on the manual to see which trip class your overload is at. I will explain further the trip classes on another video because it's a big topic on its own. Okay, now I will show you how does the trip test work on an overload. Firstly, we'll switch our overload on, and there is your trip test on your side. You're also going to use the trip test for our testing. As you can see, as soon as I press my trip test, my overload trips. That's what will happen on our motor when it's overloaded. It will trip the circuit. The thermal relays work on a thermal effect of electrical current which disconnect the contact. When it exceeds the intended and the set trip current, the circuit will trip or the contact will be open. Now we're going to be using the trip test to test our overload relay. We'll put our overload on, and then our multimeter is still at continuous mode. So now we'll start with the testing of our main contacts. We'll start our test by testing L1 and T3. As you can see, there is continuity. There is also a resistance. Let me just switch on the screen and test again. There is continuity. It tests L2 and T2. There is toning. We test T3 and L3. There is toning of the circuits. Now we do the trip test. As you can see, our circuit is open. L1 and T1 is open, L2 and T2 is open, L3 and T3 is open. So that's how we test our overload relay. As you can see, this overload relay doesn't have the auxiliary contact, which is the downside of it. That's why I also have with me There's Niger thermal overload, which I'll be testing next, because this is usually the one that we have mostly in the plants, the one that have the feedback contact. Thermal overload relays are used to provide overload protection, open phase protection, and a protection against unbalanced current of a motor. They work by the thermal effects of an electrical current to push the action mechanism to make or break contacts for protection of your electrical appliances. As you can see, this Niger thermal overload is different with the ABB. Here we have contacts which are connected to our main contactor, and then we will create a motor starter, because you can't use an overload alone on a circuit, especially this type of an overload. Even the other type of an overload, you can't use it alone in a circuit. You have to have your circuit breaker and your contactor for your switching. The good thing with this overload, we have auxiliaries, normally open and normally close. The main parts are the thermal element, action mechanism, bimetallic sheet or a metallic alloy, depending which overload or thermal overload you have. And then you also have the contacts, which are the one that you connect to your contactor. And then you have a reset button, and then you have your adjustable circuit setting or a trip class selector, and then you have a button for manual or auto reset, and then you have your trip indicator. We'll go through them one by one. Please like and subscribe for more. I continued with the video on the following day. The video for practical number 1 is in the link on the description. On this practical, I will first show you how to use the manual and auto selection button, because the other buttons we did have on the previous video. Okay, when your button is on manual, as you can see, there's an indicator there which goes yellow when there is a trip circuit. You'll need to press reset in order for you to reset your circuit. As you can see right now, it's tripped and it's on here. There is an indicator there that's showing yellow, so you'll press reset and then the yellow will go away. That means your circuit is reset. And then the red button there is your trip test. As you can see, I've pressed it. But now when you're on auto, it means when you press your trip test button, as long as your circuit is still on the working condition, it will reset automatically. There is no need for you to press reset. But it's advisable to always put your switch on manual, so that you come and confirm, or you'll be able to be notified when there's a trip on your circuit. At the end of the video, I will explain in details how the thermal overload actually work inside. Okay, let's start with the testing for now, and then I'll explain the functioning and the operations of a thermal overload. Firstly, you need to put our meter into continuous mode, because I remember this video was taken on the following day from the practical one video. I had an emergency to attend to. The first test that we'll do, we'll test our auxiliary contacts. We have normally closed contacts, and then we have also normally open contacts. We'll start with normally closed. As you can see, it's working fine. And then we'll do our normally open contact. It should be an open circuit. We'll also be using the trip test to test when the overload is tripped. So now we are testing the normally open. It should be open. As you can see, it's open. And then we use our trip test. You see, I've pressed the red button, which is our trip test, and then I'll reset, and our auto selector is on. As you can see, I've put the trip again. It's tripped. Then I'll reset. So now we test the normally closed contact. As you can see, it's closed. Now we trip the circuit. It is open. And then reset the circuit. As you can see, it's closed. This is basically how you test your overload relay. As you can see, the trip is off. Test the normally open again. Now we are going to test the main contact, which will be ideally L1, which your live in L1 and L2 and L3, which your T1, T2 and T3. Our first test will be L1 and T1. We should have continuity. We should be reading ohms. As you can see, I'm not getting it right. Okay, now we are testing L2 and T3 and T2, sorry. Now we're testing L3 and T3. As you can see, there's continuity. There is also ohms. Now we do a trip test. As you can see, there's still ohms. Okay, I'll explain just now why do we have ohms even after we've tripped the circuit, but it was a different case on our previous overload. This is where the thermal effect comes into explanation. Now we'll test our auxiliary contact that goes directly into our contactor, which is normally closed, and then we'll trip the circuit and then test again. As you can see, it is open. And then we just trip our circuit again. As you can see, there is continuity. We are tuning also the circuit. Okay, now I'm going to explain why. Now I'm going to explain why on a thermal overload you don't have you still have continuity even after it's tripped, and on a overload relay you don't have it. It all goes down to the operations and the functioning of a thermal relay. The reason is, on a normal working motor or an unstressed thermal overload, the heat produced by the thermal element will bend the biometallic sheet, but it isn't enough to trigger the contacts of the relay. That's why it doesn't open it. You still have the contact. When the motor is overloaded or when there is an overcurrent, the bending degree of the biometallic sheet strip or a metal alloy, depending on which overlay you're using, it increases to push the guide plate and separate the normally closed contacts, which then causes your thermal overload to be on a normally open contact. That's when you will not have the continuity between your L1 and T2, because the bending degree is above the trip class of your thermal overload. That is why on the thermal relay, especially those Niger one, you need to use the motor starter, which is your contactor and your thermal overload, and then you'll take your auxiliary to switch off your contactor in case of any overload. On the next video, I'll be showing you how to do the circuit diagram or the circuit wiring of the starter. Please like and subscribe for more, and watch for more videos on the link on the descriptions.